Hey guys, we're back for another lesson here. This is lesson number 5. Division of powers. So pretty much it says what exactly it says there. We're going to be dividing powers, and there's a special rule amongst that happens when you divide these powers. Here is your organizer again that you're going to have. And if we use the organizer the way that we need to with division of powers, and we can be able to see our rule here develop here in a minute. So basically what's going to happen is you're going to be given a question. You're going to give two powers to divide. You're going to see it written in two different ways. You can see it written either as a fraction, which means to divide, like 4 to the 6th power divided by 4 to the 5th. You'll see it that way. Or you may see it as 4 to the 6th power with a division sign in between to the 5th. It's the same form. But what I want you to do is when we expand these out, do we need to be able to look at these and see how do we write them out with expansion form. We're going to write them out as kind of like a fraction form. Okay? So when we do our exponential form, when I do our expansion form, we're going to write it out in kind of like a fraction form in that case. So let's take a look at the first one here. So here's our question. We want to take 4 to the 6th power and divide it by 4 to the 5th power. Or you may see it written like this with a division sign. Basically, that already is our question, so we need to ask ourselves, okay, remember, reciprocal. Do we have any negative exponents here? We don't have any negative exponents, so we're okay. So now we want to expand it out. So if we expand this out, let's write it as a fraction. Our numerator had 4 to the 6th power. So that means we have 6 4s up here in the top. 1, 2, 3, 4, 5, and 6. And in our denominator, we had 5 4s. 1, 2, 3, 4, 5. Okay? So now we got to think about, well, what are we doing here with these using our expanded form here? Oh, there it goes. So what happens is we think about one whole. We think about what is a one whole. In this case, we think about if I have 4 over 4, I know 4 over 4 equals 1. If I have x over x, that equals 1. When you have the same numerator and denominator, it gives you 1. So let's look here for a minute. I have these right here that give me 1. I have a 4 over 4, a 4 over 4, a 4 over 4, 4 over 4, 4 over 4. And that's all 1. And anything times 1 is 1. So what am I left with? I'm just left with a 4. So this problem here is just in standard form 4, or 4 to the 1st power. Now think about that for a minute. How did we use the 6 and the 5 to get 1? What did we do to 6 and 5 to get 1? Think about that as we look at another example. All right, let's try one with variables this time. It is, let's write it out this way, x to the 3rd power divided by x to the 2nd power. All right, and same way, do we have any negative exponents to flip? No, we don't. So it's out. We're going to write it as a fraction. Remember, this is my numerator, this is my denominator. So I'm going to write it out. On the top, I got 3 x's. And on the bottom, I have 2. So what happens here? Let's check for my one wholes. So let's see here. Well, I got this right here. X over x makes one whole. So that's 1. So they're canceled out, or they're 1. I got another one right here. They're gone. So what am I left with? I'm left with 1x. So my answer there is x to the 1st power. Same as what I got for the top part, but this was 4 to the 1st power. But what did I do with my exponents, the 3 and the 2, to get the 1? Think about it one more time. What do you think I did? So let's try one more here. Let's look at one here. Let's see if it works the same way. Let's do this one. 2 to the 6th power divided by 2 to the 2nd power. All right. I'm going to say I think the answer is going to be 2 to the 4th power. Let's see if the answer is 2 to the 4th power. See if you can pick up why it's 2 to the 4th power. What did I do with these exponents? By showing you with my expanded form. I don't have any negatives, so I'm going to not take the reciprocal. So how many 2's do I have on top? I have 2. I have 6 of them. 1, 2, 3, 4, 5, and 6. That's in my numerator. In the denominator, I line them up with my other 2's. And then I look to see which ones pair up. Which ones give me a same numerator and denominator. I've got one here and one there. So those cancel out, or they become 1. And how many do I have left? 1, 2, 3, 4. 2 to the 4th power. And when I do 2 to the 4th power, that's 2 times 2 times 2 times 2. You end up getting your standard form to be 16. Well, what did we end up doing there? It looks like that we subtracted those, didn't we? Taking away 2 groups there from the 6 that I had, I ended up with 4. I had 3 groups up here, it took 2 of them away, and I ended up with 1. I had 6 groups up here, I took 5 of them away, and I ended up with 1. Let's see if that works out again. Let's see if, do I subtract those 2? Let's see if what happens. Let's try a different one here. Let's see, what if I do throw a little different oddball at you here? Let's see if it works. Let's try y to the 7th power, and I'm going to divide it by y to the 4th power. So if I do what we did up here and subtract these 2 exponents, the 7 and the 4, and keep my base, the base is y, should get 3. Let's see if that happens. So let's look here. So I'm going to put it here, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. And let's find the ones that pair up. I got 1 group there, 2, 3, 4 groups there. 4 groups I took away. How many y's are left? There's only 3 of them, just like we had here. So that doesn't work. 7 take away 4. Gives me my answer, y to the 3rd power. So basically all I'm doing here is keeping the base and I'm subtracting. Let's see if it works for our negatives. So let's see here. What if I have 3 to the 3rd power? And I'm going to divide it by 3 to the 6th power. Alright, let's see what happens. Don't have any negatives there. Let's look back here. Let's see what happens. I got on top, I got 3 3's. And on the bottom, I got 6 3's. Okay. So let's see what I have paired up. So I'm taking 3 of them away. 1, 2, 3. Oh, they're gone. So I took 3 away, and I have 6 on the bottom. So I have 3 down here at the bottom. But my answer is not 3 to the 3rd power. It's not 3 to the 3rd power. Because remember, this is in the denominator. So it's going to be 1 over 3 to the 3rd power. Because remember, that's the same as saying 3 to the negative 3rd power. Because when I subtract those, I get negative 3. It's the same thing. 3, take away 6, I get negative 3. When I took the reciprocal of that, I get the same thing. So both of those are the correct answer. All right, let's try another one. What if I do this one? Let's try n to the 4th divided by n to the 3rd power. Let's do 8th power. If I do 4 take away 8, I'm going to get n to the negative 4th power. Because 4 take away 8, it's going to be negative 4. Let's see if that works out. So I have on the top here, my numerator, I have 4 n's. On the bottom, I have 1, 2, 3, 4, 5, 6, 7, 8. I find my pairs. I got 1 pair, 2 pair, 3 pair, 4 pairs. Those make 1's. But Mr. O, I got n to the 4th power down here at the bottom. Well, yeah, I do. But remember, this right here, if I take the reciprocal of this one, and flip it over and then change the sign, those are the same thing. So this is the same thing as that. So it's the same thing in what you have. Doesn't matter if you got positives or negatives or whatever you've got. It's the same thing that works. If I give you another one, it doesn't matter even if I throw a negative in here. Let's see here. Let's go with 6 to the second power divided by 6 to the negative third. Okay? So if I follow the rule that says to subtract these, take out my calculator here and I can say, okay, what do I got? 2 take away negative 3 gives me 5. So I got 6 to the fifth power for my solution. My standard form there would be 6 to the fifth power, which would give me 7776. So basically all I did was subtract those. If I wanted to do an expanded form, I can show you what happens there. This right here would be a fraction. It's kind of complicated to show it in this way, expanded form. But if you have this here, I can flip this over here, and you would end up having your 6 and 6. This right here flips over to the other side, adds 3 more to it. There it would be. So basically all we're doing here is we're going to subtract the exponents, and we're keeping the base, the big number, the same. So when you do these, you see that we all have the same bases. All the bases are all the same. And all we're going to do is just subtract those exponents and keep the base the same. Now, sometimes we may have to rewrite them if we get a negative as a positive, such as up here in the top. How we got a negative number, we had to rewrite it as a positive. So sometimes we may have that. So just in case, if you have one, I'll put one last example here. I don't know. 7 to the first power divided by 7 to the fourth power. When you subtract the 1 and the 4, you get 7 to the negative 3. Remember, what else can you write that as positive? Take the reciprocal of it. That means flip it upside down and keep the exponent flip signs. So those are both the same. So be careful when you see those. But this is what you'll do here. There'll be an assignment for you to do to check these. Check these and then do those and check those, and then there'll be an assignment for you in some IXLs. Thank you very much.